Hi everyone, and welcome back to SALT Talks. I'm Rachel Pether and I'm a senior advisor to SkyBridge Capital, a global alternative investments firm, as well as being the MC for SALT, a thought leadership forum and networking platform that encompasses business, technology, and politics. SALT Talks is a series of digital interviews with some of the world's foremost investors, creators, and thinkers. And actually, our guest today is really a combination of all three. Just as we do at our global SALT events, we aim to empower really big, important ideas and provide our audience a window into the mind of subject matter experts. Today, I'm very excited to be welcoming Dr. Finian Tan to SALT Talks. Finian founded Vickers Venture Partners in 2005 with 4 partners, and he's grown the company to become a $3 billion top-performing global deep tech firm. They invest in early stage companies with technical solutions to solve large global problems. And one of them happens to be, spoiler alert, a T cell based vaccination platform that can be designed for COVID-19. Before starting Vickers, Finian was a managing director at Draper Fisher Jurvetson. As the founding partner of its Asia Pacific operations, he led the investment into Baidu and remained its largest backer until IPO. Prior to this, Finian was Deputy Secretary of Trade and Industry for the Singapore government. He received his Doctor in Philosophy and Master of Philosophy in Engineering from Cambridge, and he received his BSc in Engineering from the University of Glasgow. Finian, it's a real pleasure having you with us today.
Thank you very much for having me, Rachel.
Now, you're a difficult one because I just want to talk about so many things. I want to talk about your role with the Singapore government, your investment into Baidu, the work that you're doing with Vickers Venture Partners, and obviously go into more detail about the COVID vaccine. But before we get into some of these in detail, tell me a little bit more about your personal story.
I was with Goldman Sachs in 1996. I was based in Singapore and then London and New York. I was in charge of trading for Asia for a company called J. Aron, which was part of Goldman Sachs. Running Asia from New York wasn't good, so I decided to come back to Asia. I chose Singapore. I'm a Singaporean. So in 96, I came back, and as soon as I got back, I was approached and asked to serve in the administration as a Deputy Secretary in the Ministry of Trade and Industry. So it was a chance to serve my country. I was then a young man of 34, couldn't quite say no, so I became Deputy Secretary. And part of my role was to help make Singapore into a Silicon Valley for Asia. As some of you will know, Singapore's per capita income is pretty high. It's about the same as the US. So the next stage of growth is entrepreneurship and innovation driven. So it was natural for them to want to give me this task. And I made 3 recommendations. One was the setting up of a $1 billion fund to jumpstart venture capital. The second was the setting up of a physical science hub where people can live, work, play, study. And the third was an interministry committee to change rules and regulations to allow startups to thrive. So the government approved all 3 and made me the chairman of all 3. And that started my life in venture. I fell in love with venture. Yeah.
And
yeah, go ahead.
I was going to say you've obviously been very successful as a venture capitalist as well, and we can touch on that shortly. But you mentioned that Singapore was aiming to become the next Silicon Valley, and I know many cities around the world have this aim. Do you think that that's sort of a reasonable aim to have, and can you just create it using capital? I'd love to know your views on that.
Well, many cities and countries have tried it with varying success. It's very difficult to do because you have to create an entire ecosystem, and creating an ecosystem is never easy. For example, right, if you wanted to create a Kruger National Park, that's very hard to do because you can't it's not like a zoo where you bring animals and you feed them. In a Kruger National Park situation, you would have to allow them to feed on their own. So You have to have the grass, the earthworms, the rabbits, the deer, and then the predators, and the whole thing needs to go through the circle of life. And it needs to be self-sustaining. And no matter what you do, there will be gaps. There will be gaps where you have to feed some groups in order to keep them alive for a while, and eventually reach a self-sustaining cycle of life. And in most countries, it's just too difficult to do. They have to feed everyone, just like the zoo, where you feed all the animals, and so you can import all the animals you need. But if you want to create a circle of life for venture capital, you need every single part of it. And you need the country to have the political will to do this, and the capital and the R&D spend, and it must be in the right R&D environment. It must have the right stage of growth. So I think if any country could do it, Singapore probably is in a good place, but it's not quite there yet.
That's great. I love that analogy of comparing it to, a zoo or a natural ecosystem like the Kruger National Park. And was that something, is that really what, I guess, where your love of venture was born? Maybe you could tell me a little bit about that part of your journey as well, and this, really getting this passion for venture capital and early stage companies.
Yeah, venture is really a blend of finance and tech. I had already been finance trained at Goldman. And since I did my PhD in engineering at Cambridge, I'm a tech guy. So it was a nice combination of the two skills. So that's why I decided, that's what I'm going to be. And I joined a firm called Draper Fisher Jurvetson ePlanet Ventures. They're pretty well known. DFJ is well known for Tesla, SpaceX, SolarCity. But at that time, they were well known for Hotmail and Skype. So I joined them as the founding partner for Asia. And my first investment was a small company at that time called Baidu, which, as you know, became the Google of China. So we took a very large stake in the company. We became the largest shareholder of the company at the IPO. And so when Baidu listed in 2005, it was an extremely successful IPO. In fact, it still holds the record of the best performing IPO in Nasdaq's history. So that was very good. I had a lot of publicity. I appeared on front covers of magazines, including Forbes. They called me the Baidu backer. And with that behind me, I decided to start my own fund. And that's how Vickers was born.
And what made you believe in Baidu at such an early stage then? What was it about the company and, its story and its prospects for growth?
The year 2000 was a very difficult time because it was the first time that the internet came to the fore, and there were thousands of companies. In fact, anything that had 3 W's in front or had .com would shoot through the roof. They were worth billions on air. So it was difficult to discern what would work and what wouldn't. So I decided to, in my book, draw a line in the middle, put what I understood for sure would happen on the left, and on the right, put things that I was still a little unsure about. So the right side started filling up, Ask Jeeves, Inktomi, InfoSeek, InfoSpace, Yahoo, Amazon, eBay. I wasn't sure about the business models because they were all burning cash just for eyeballs. So it started filling up. I stopped, and then I said, okay, what do I know for sure about the world? Number one, I knew that China would grow. I was absolutely confident that that would happen. And number two, I knew that the internet would grow, and that's it. So I asked myself, what could I invest in that will surely make money if these two things that I felt would happen for sure happened? And I concluded that it would be the operating system of the internet in China. But what's the operating system of the internet? Is it Cisco? Is it the Explorer? I concluded that it was search, because that's what everybody does. And so I asked the team, what do we know about search? Not very much. So we went out, we spoke to all the incumbents, we spoke to all the customers of search, we spoke to all the companies that have come to the DFJ family, We spoke to those people that have gone to our outside of the DFJ family. And after about a month or so, we huddled together and we decided that Baidu was the one that really, stuck out like a tall poppy. And the reason is because, search is very objective. It's speed and relevance, and you could measure. So Baidu had a new architecture, which was very related to how many people search for a particular item and clicked on it. So it was linked to search results rather than using a directory. And we felt that that was the best, and it was like a magnitude better. And so we decided to invest in Baidu.
Fabulous. And I think that sort of, I guess, appreciation and love of data has also carried into, Vickers Venture Partners. I'd love to know more about that, because I think your offering is so unique here. Even just, we were talking before about the number of founding partners that are actually doctors. So, let's tell me a bit more about Vickers Venture Partners and the focus on deep tech as well.
We didn't start off that way. We started as more or less a generalist VC, always drawing the line in the middle and asking ourselves, what do we know and what we don't know, and then trying to invest in core areas. But we were industry agnostic, and so we would invest in fintech, games, e-commerce, all sorts. After a while, we realized that we were very good at some parts of our business and not as good in some. So we decided to split risk into three buckets. One is technology. Does it work? IP, are you in the lead? Is it going to be a monopoly? And third, the market. Will people buy your product? We were not so good at guessing the market. I can't even guess what my wife likes, let alone my children, etc., let alone 7 billion people. We only knew what we liked personally. And sometimes we tend to extend that erroneously. But we were pretty good at guessing or intellectually guessing whether a tech would work, especially if it was our field of interest. And so we decided to take only one risk rather than three. And we focused that only on the tech. So will it work? Market must be known and ready before we will look at it. And we don't take IP risk. You have to own the IP, you have to be in the lead. And after we did that, our performance really skyrocketed. Our home run pool increased from 28% to 50%. Our failure rate dropped from initially it was 34%, then dropped to 20%, and now including co-investments is about 6%. So that's when we started climbing up the ranks, and today we have about 3 billion under management across 7 offices globally.
Fantastic. And does this approach mean that you're more highly concentrated, like it's more of a high conviction approach, I guess, than some other venture capital firms?
Well, we're very different. So let me just give you a few examples. When I talk about tech risk, and I talk about not taking market risk, it requires some elaboration. People often wonder what kind of deals will not have market risk. Everybody has market risk. All companies have market risk. Not quite. I'll give you an example. Let's take a cure for cancer. If you actually had a cure for cancer, the number of patients per year is known. The incidence rate is known. The mortality is known. The morbidity is known. The prevalence is known. Everything is known. The only thing that's unknown is, will the drug work? Will it get FDA approval? How efficacious is it? How toxic will it be? And that's a risk we are willing to take. It's a calculated risk. And it's nicer when we reduce the risk to one bucket. And then we focus on building strengths in that bucket. So that's why we have so many PhDs and doctors, because we doubled down on what we were good at and cut out all the other noise. So in most other venture capitalist investment committee meetings, the IC meetings would be very noisy. What do I mean by noise? One guy brings an e-commerce company, one guy brings a, bike sharing, a ride hailing, a game company, a social network, and one tech company. For us, it's easy, ride hailing out, e-commerce out, logistics out, game company out, social network out, tech. Okay, that's interesting. Now, we would split that further. So we've decided we will take tech risk, and we've decided that we will only do holy grail type breakthroughs. So breakthroughs that are so impactful that it will change the world, and it will have a paradigm shift that will basically make everybody change the way they look at this particular problem. But if it's a holy grail breakthrough that's still a dream, that's too risky. If it's a holy grail breakthrough that's already been made and everybody knows about it, it would be too expensive. So we focus on a small Goldilocks zone where it's a holy grail breakthrough that has actually already been made, but requires the last push with data to convince everyone of this new paradigm shift. And that's the only thing we do. So as a result, out of the 5,000 deals that we receive, in the past, maybe 4,000 would qualify. Today, less than 100.
Well, that's a very easy filtering and screening mechanism, isn't it? And yeah. I do want to talk, you know, you mentioned cure for cancer. Obviously, that's a very nice sort of analogous to a vaccine for COVID. But I did just have an audience question come in, which is relevant to what you've just said. It was that if the market is ready for a company's products, i.e. if the market risk is known, does it often mean that your companies are in late stage when it comes to investments?
Not necessarily, because if it's too late, then it's too expensive for us. So it would come in under the second bucket. So it's typically the third bucket, which is the Goldilocks zone, where it's a breakthrough in our view that has already been made, but people don't yet believe. And the reason why they don't yet believe is because they haven't dug deep enough. So let me give you an example. We have a company called RWDC. They have a biodegradable plastic alternative. And, you know, in order to be an alternative to single-use disposable plastic, you need to meet 3 criteria. Number 1, you need to be as cheap as plastic. Number 2, it must feel like plastic and have all the material properties, waterproofness, high temperature, etc. And number 3, it must be biodegradable. We've been hunting high and low. We had been hunting high and low forever. And we found many, many companies that met 2, but not 3. Finally, we came across one company that could do all 3. And this was the only company that we could find. But they only had a small plant of 250 tons. So they had to scale from 250 tons to 25,000 tons. So there was an apparent prototyping risk. And as a result, many VCs were holding back, you know, unsure how risky this was. We rolled up our sleeves, went to the company, and in the midst of our due diligence, we found that the company had already tested their microbes in this big full-scale tank of a 25,000 tons factory that we'll be using. And they manually poured all the microbes and the nutrients, and they grew the material manually. So which means the microbiology has already been tested. So what's the rest? The rest are movement of oil through pumps, centrifuges, and pipes. And this is an old academic study. It's a 100-year-old subject. You learn it in fluid dynamics. I have moved such oils in the refinery at Shell, where I used to work before, 10 times larger. And we could calculate it to the decimal. So actually, if you come to think of it, since it's a mixture of engineering and microbiology, and both of them would work, 1 + 1 would be 2. So we felt that this is a breakthrough that had already been made. We invested. The company then started increasing its scale and talking to customers. And today it's almost a unicorn. They just closed the Series B round. It's a staple round with B1 and B2. And after the milestones are hit in a few months, there will be a unicorn. And we invested at, you know, in the tens of millions, just because we were, I guess, conscientious enough to immediately fly and dig deep instead of being affected by noise. You know, if you had 6 companies to look at, one was a social network, one was ride hailing, one is going to be Twitter, one's going to be the next, Angry Birds, and then you have a tech company that looks a bit risky. The priorities are different. For us, we drop everything. That's the only thing we're looking at. We'll fly there tomorrow and we'll roll up our sleeves. And if it's the holy grail breakthrough that has already been achieved, but just needs a little bit of push, that's the one we want.
Excellent. And I guess that deep knowledge of the company really de-risks the investment for you, doesn't it? Because you have
Absolutely, yeah,
so much. So you mentioned you work on things, or you look at investments where the market is known, the market is huge. Obviously, we would be remiss not to talk about the work that you're currently doing in the COVID vaccine development space. So one of the companies that you're focused on within Vickers Venture Partners is Emergex. Let's please share with the audience the work that you're doing here, because it's really quite phenomenal.
Yeah, I mean, this pandemic is affecting all of us, and everybody must be asking the question, when will life return to normal? I mean, like really normal, with parties and stadium events and rock concerts and going to clubs and not wearing masks and not social distancing anymore. That can only come from a vaccine that can eradicate the virus. So when I say eradicate, I mean like smallpox or yellow fever or polio, where the virus disappears, or SARS-1. It cannot be the flu vaccine type of efficacy, because the flu is still with us. And COVID-19 is much more lethal than the flu. So if all the protection you get is similar to the flu vaccine, which by the way is only 10% to 60% efficacious, life will not return to normal. Dr. Fauci was just interviewed recently, and he said that if the vaccine is only 50% efficacious, we will still be wearing masks, we'll still be social distancing. And unfortunately, the technology that's being employed by all the lead horses in the race, because there are, by the way, 177 companies today racing to the vaccine finish line, 167 of them are working on antibody approaches, which are very similar to the flu vaccine. All of them working on the surface protein. You know, the virus has a spike. Everybody is trying to mimic the spike. And I don't think that it's going to result in an eradicating vaccine. It will reduce mortality, it will reduce morbidity, it will reduce transmission, but life ain't going to return to normal until we have an eradicating vaccine. Now, I mentioned yellow fever, smallpox, polio, etc. They were eradicating because they induce T cell responses, not just antibody responses. And thankfully, there are 10 of us working on T cell vaccines. And I think Emergex has a very good shot at it, maybe the best shot at coming up with an eradicating vaccine, maybe 7-8 months from today.
Wow, that's that's a timeline we can all look to with some optimism. What are some of the, you mentioned 167 out of 177 are working on the, the antibody vaccines. What are some of the disadvantages of this? Like, do you think it will create a false sense of security almost, or do you see this more as a kind of stopgap until we have something that can actually eradicate the virus?
Okay, let me explain the difference between antibodies and T cells. When the virus enters the human body, it starts with moving in the fluids, right, through the lymphatic and the blood. So viruses are small little bugger with little spikes. And they will encounter antibodies in the human blood and the human lymphatic system. Antibodies are little Y-shaped things that exist in the human body. And we have all types of antibodies for every single virus that we have ever encountered and will probably ever encounter. So we have antibodies for them, but not very much of each type. So let's say we get virus X. Virus X enters the human body and through the blood, it will encounter some antibodies which don't fit. But one of them will fit, and let's call that antibody X. It will fit virus X like a lock and a key. Once it fits the surface of the virus, it will then say, oh, I need to neutralize this, and I need to build memory for this. So they will then start to build the army, which will take 7 or 10 days, so that you have an army of antibodies that will neutralize these virus X. What a vaccine tries to do is, a vaccine tries to look like virus X, but without the toxicity. And they would copy the surface, and typically, since it binds to the spike, they just have to copy the spike. They don't have to copy the whole virus, because the Y only joins with the spike. It binds with the spike. So that's what everybody's doing. 166 of them are designing vaccines that look like the spike of the virus, using different technology. Some of them, they take a adenovirus, and then they use peptides to make the spike, and then they glue it with carbohydrates. Some other people use inactivated coronaviruses, which already has a spike. And some of them are using mRNA, messenger RNA, which basically hijacks the manufacturing part of the cell to produce the vaccine, but trying to mimic the spike again. So antibodies really focus on the surface of the virus, and try to mimic the surface of the virus. What happens if a virus escapes an antibody and enters a cell? That's disaster, because if it escapes the antibodies, the shield of antibodies, and enters the cell, it will then do two things. It will start to multiply frantically and build thousands of itself using the manufacturing capacity of our cell. The other thing that happens is the cell will try to kill the virus, and it will chop up the virus into little bits of viruses. And these bits are then displayed outside the cell and become an antigen-presenting cell. And you have these little bits of virus outside the cell. And that says that I'm foreign. Our T cells will then come and destroy them based on recognizing the little bits of the virus. And only a few T cells, actually one type of T cell, will recognize one type of bits of virus. And that T cell will then clone itself and make armies, just like the antibodies did, so that when they see infected cells and they recognize all these little bits, they will kill it. Killing infected cells is so crucial, because infected cells are a factory that produces more and more of the virus. And it is the infected cells that cause the symptoms. Imagine if the lung cell was infected, then you can't breathe. If other parts of your body, gets infected, then that part of the body will not work very well. And you get pus, you get liquids, and you get pneumonia, etc. So you have to destroy infected cells to prevent the factory. You have to destroy the factory from making clones. Now, if you wanted to induce T cells, you have to mimic an infected cell. You don't mimic the virus. And I just said, what does an infected cell look like? An infected cell has little bits of virus parts stuck to it. You don't have to copy the whole cell, you just need to copy the viral parts. And these viral parts are actually don't really come primarily from the surface of the virus. They come from the inside of the virus, because there is more volume than surface area. I'll give you an example. When you eat meat, not many pieces of meat have skin, because it doesn't have the surface. It's the inside of the intestines don't have skin, the liver, the heart, the stomach, and all the flesh does not have skin, right? So you have to copy the steaks of the virus rather than the horn of the cow. And the steaks of the virus does not look anything like the face of the cow or the horns of the cow. So antibody approaches copies the horn of the cow, and we are copying the steaks that a cut-up virus looks like. So what are the 10 of us doing that's different? I think that most of the people doing T-cell vaccines today are kind of intelligently guessing what it will look like. So they use AI, they use computers to predict how will the virus be cut up by an infected cell. So maybe you would have the nucleocapsid, which is like the intestines of the virus. And some people say it comes from the flesh, and it maybe it's 30%, 20%, 10% of the three different parts, because that's what happened to flu, that's what happened with SARS-1, etc. And they use computer prediction. Emergex has decided to do something different. They decided to do it from first principles. So what we did was we infected all the human supertypes. There are 6 supertypes in the world that covers 98% of all blood types. And we see what happens when these supertypes infected cells, what sort of bits of virus are displayed. And we collected all of them, and we did a mass spectrometry. And so today, we are the first in the world to announce that we now have the library of peptides that expresses all the supertypes in the world, all the 98% supertypes of the world, and what their viral parts will look like. So we're now in a good position to produce a vaccine that looks exactly like an infected cell. So we're very optimistic that it's going to work and work very well.
I mean, that's very refreshing to hear. You know, I think it's fascinating what you're talking about, mimicking the infected cell. How would that work in terms of mutations or COVID-19 different strands? Because it's T cell.
Very good question. Because it's mostly internal proteins. So generally when viruses mutate, I mean, I'll give you an example. If somebody wants to disguise itself so that the police doesn't recognize it, it doesn't change its liver, you know? It just changes its face, wear a hat, you know, shave. So generally surface proteins mutate and internal proteins don't mutate so much. So since we are mostly internal proteins, we can cope with mutation. And because of that, the efficacy of T cell vaccines lasts 30 years. But efficacy of the flu vaccine wanes 16% per month, mainly because of the mutation of the surface protein.
Wow.
So we are talking about a potential T cell vaccine that will be a single shot and will last for 30 years and can protect us from every serotype of this disease.
So we have one question that's coming from the audience on this, and we actually have about a dozen other questions that have come in. But I do want to ask one final question on the vaccines. When you talk about efficacy, and when you say 50% efficacy, does this mean like you would reduce serious symptoms, or does it just mean that in 50% of the cases it's actually effective at all?
We don't know. But what we know is you see, the thing that causes an infection to become a disease, 2 things. One, it's viral load, and 2 is viral diversity. So, and that pushes it past the bottleneck and then becomes a serious disease. So if the antibodies can reduce viral load and reduce diversity, that's good for that person, but it tends to encourage mutant escape mutants. So if you have, for example, if you have antibody X and virus X comes in, then it's blocked, right? And then it mutates into virus Y, and that's the one that goes out and infects somebody else. So suddenly it doesn't work anymore for the other person, but it worked for you because time is the most important. The human body will produce its own T cells, and it will also produce its own antibodies. And it's the best vaccine. It's the best defense. The problem is time. Because it takes a while to build the army, sometimes a person gets overcome by the disease and dies. Sometimes he gets very sick before he recovers. And sometimes it's asymptomatic because the viral load and diversity wasn't very great. And you had the time for the defense to be built. So the key about our T cell vaccine is we have the army of T cells on day 0. it might not give you complete immunity. It will not stop the infection, but it stops the disease and converts the disease into something that's asymptomatic, asymptomatic, or clinically no disease or very light disease. And that gives you gives you the time for your body's own defense to grow its antibodies and to grow other types of T cells to defend against this virus. So in fact, our vaccine is a combination of a T cell vaccine that builds T cells on day 0. And then when the infection comes, the infection becomes the boost. It's the prime plus boost strategy. So it's like when you get a booster shot, right, of a vaccine. So you get the prime T cell, and then the infection is actually a boost that brings all the other defenses. And together, it gives you real complete immunity.
And so with Emergex and, you know, the work you're doing, that is obviously a company that has huge global impact. I mean, it could potentially touch every one of us. Is impact a particular focus area for you?
Well, we don't go out to make an impact, but because, you know, our criteria is a holy grail type breakthrough, it naturally implies an impact, and generally would be a very impactful company if we achieve success. So there's some risk, technological risk. And by the way, when I say our failure rate is 6%, that's measured by dollars and not number of companies. Number of companies is larger than that, but we don't put more money after bad. So if it doesn't work out, we don't put more money, and as a result, in dollar terms, our failure rate is only 6%. But in terms of number of companies, it's larger. We don't always succeed. We don't always spot them right. Sometimes we encounter risks that we didn't foresee. But generally, we're good. I think more than 2/3 of the time, we're correct. So we're very excited about Emergex, not just because we believe we can potentially produce an eradicating vaccine, but also because of how quickly we can manufacture it. Because of our delivery mechanism, we can actually put it on one day, put it on a microneedle patch that could potentially be put on your arm for a minute, self-administered, no cold chain required because it's an inanimate material that we're using. So instead of using a live virus as the carrier, we are using a particle that's stable and at room temperature. So that's very exciting. It will take us months to produce for the world. And it's so easy because you don't need somebody to administer it. You don't need a syringe. You don't need a refrigeration, etc. Our first clinical trials will be with a syringe, a microneedle syringe. But as we improve this, we can theoretically put it on a micro patch or a Band-Aid.
That's incredible. And I think that lack of cold chain is also, I mean, just that speed for getting it to market, not requiring cold chain, and takes up that logistical burden as well. So that's
you know, some of the drugs that are currently, some of the vaccines that are currently going through clinical trials require -80 degrees centigrade to store, and that's a logistical nightmare.
Yeah, that's very cold. As someone who lives in Abu Dhabi, I can only appreciate how cold that is. We just have a couple of minutes left, and we do still have, you know, so many questions that have come in. So for any audience questions that we haven't had time to get to, please do just let one of the SALT team know, and I'm sure Dr. Finian would be happy to answer them. But I would just like to end on maybe a sort of softer question for you, Dr. Finian, and maybe you could share with the audience what is, you know, one of the early lessons that you learned when you ventured out on your own.
Yeah, well, the biggest lesson was because of success, sometimes you think that you're pretty good at this, and then realize that you're actually not so good at this part of it, but you were good on, you know, on the other side. And that took a while. So we had some tough times, companies failed, and then later with looking through data, we realize and manage to pinpoint why we were making mistakes. And we were going into a territory that we were not necessarily the best at, trying to guess the market. We're not good at crystal ball gazing. Some people are pretty good at that, but not us. We're boring tech guys, and we like to take our time and go through the nitty-gritties of tech and trying, almost like doing a PhD itself, trying to figure out and learning about a particular topic. So for example, we had to dig in very deep into immunology to understand the difference between antibodies and T cells, and the difference between using computers to predict and using first principles. Why do RNA viruses mutate? How do they mutate? How do you solve the problem? Why is the flu vaccine a wrong approach? So that took a lot of time and a lot of rolling up of the sleeves. Yeah, but we continue to make mistakes and we continue to miss good ones. That's the nature of the game. But the beauty of venture capital is you don't need to be right all the time. But when you're right, you're really right. Baidu is today worth maybe 1,500 times more than when I first invested. We're listing a company now in China that's 110x from where we invested. And in 7 months, we could get an approval for Emergex. And if we do, this will be another 150, 200x type returns or even more. The bioplastic is another very, very interesting company. Recently, we invested, well, about a year now, we invested in a company in Calgary that has a geothermal solution to green energy. And, you know, as you know, geothermal is the greenest of all green energy. And that's super exciting. It's called EVER, and they found a way to reduce geothermal prices by a factor of 10. And geothermal, the earth is always hot. And I don't know if you know this, but the center of the earth is as hot as the surface of the sun.
I did not know that.
So, and it's always hot. So it's not like solar where it's hot in the day, cool at night. It's not like wind, it's sometimes windy, sometimes not windy. It's not like hydroelectric, which destroys the environment. This is always hot, so it can be base load. And you don't see anything because it's all underground. So the surface can be a nice beach. It can be, you know, a property that you build houses on. And it's like using the earth as a battery. In fact, It's an earth battery, and it's nuclear powered because that's how the earth is kept warm through nuclear.
I mean, the projects that you're working on, just for lack of a better description, they really blow my mind. And it's, you know, it's been such a pleasure speaking to you today, and I'd love to have you come on in maybe another 6 months or so to give us a progress report on how you're going with Emergex. But from my side, thank you so much for your time today, Dr. Finian. It's been a real pleasure talking to you.